welcome to Desk Ladyada.
Hey everybody, and welcome to the desk of Lady Ada. It's me, Lady Ada. With me on camera control behind the scenes is Mr. Lady Ada,
Yes,
also caring for baby Ada, who is
yes,
quietly resting. Maybe we'll squeak later. Let us
yes.
know that she's around. Okay, let's get right to it. Do we have any news updates, things you want people to know, Mr.
Nope,
Lady?
jump right in.
Okay, great. All right, this week, finally, I'm getting ready to release this Metro M7 board that is, 2 years in the making, but we can finally get parts. So we've got the nice new photos you can see here on the website. And let's go to the overhead. I can show it off. So this features super fancy silkscreen by Phil B, reminiscent of the 7 line, which is a purple line here in New York City. You get the 7 and the M, and then it's got this kind of, MTA, what station is coming up next. So IMX RT1011 running at 500 megahertz, 128K RAM, 8 megabytes of QSPI flash, and an ESP32 Wi-Fi. The ESP32 is programmed with the Nina firmware, which basically turns this into an SPI to Wi-Fi converter chip, and it does a great job. That code's from Arduino, and we're taking advantage of it. We've also done some modifications to that code as well. So this is the tester jig that we've got. We're also trying out our new Elmo. This overhead's really nice. So this is a Raspberry Pi, and even though I'm trying to convert a lot of my testers from Raspberry Pi to RT2040, the M7, and you having to do the M7 plus the ESP, all over USB is quite complicated, and a Raspberry Pi does a great job at it. So the first thing is the board has these two jumpers, and you see they're by default off. So I'm going to turn this one off. And this sets the boot mode. So when they're both off, the board, when reset, will automatically go into the ROM bootloader built into this chip. And there is a Python cross-platform code that NXP wrote that lets you load in like a secondary bootloader. So we load in TinyUF2, and then you can reset, and then then we can actually like interact with it as if it's a CircuitPython or Arduino board. Load code with UF2s, which is a lot easier, and also it's a good way to test that the USB interface is working. And one thing that's interesting is this is um, a high-speed USB. The IMX series is not just full speed; it's actually high speed. So granted, we don't use the high speed. We're still using full speed connections. But if you want to go, technically, you can push 480 megabits through, instead of 12. Go for it. So start the test. We press this button, which is button 17. And this is it loading the code, the TinyUF2 code using the SDP host. And then it's going to say, okay, you have to flip the boot select pin over to on, and it's resetting it, and then it will detect the UF2 TinyUF2 bootloader. Then it burns the Wi-Fi Nina firmware, so it's connecting through the IMX to, this is acting as a USB serial converter, connects to ESP32 and runs ESP tool, which is of course really fast, really dependable, to burn in that Nina firmware, and then it resets and does a GPIO check, and also checks that the 5-volt and 9-volt regulators are about right. You can see this one is 5,000 millivolts, and this one is about 9,000 millivolts. Test has passed, and then we have a little rainbow blinky. So whole test takes about 30-40 seconds, which is really great. Whole board is tested this way. We don't, manually test some things like the SWD connector or the stomach QT, but I've also never had an issue with those. Usually there's an issue, it's these are shorted, or there's a bridge on one of these pins, or an open, or the power supply, something is messed up. So, I'm doing not a full 100% coverage, but enough coverage that I feel confident that this is going to work out. So we're going to get these tested. This needs a clamp. You can see the clamp holes here where they would be. There should be like a clamp that comes down and like presses on this instead of me holding it down with standoffs. But that's going to come soon. And when you're done, you press this button, and that goes into, hold on, press the button. Give it a second. And then it will shut down. Then once it's shut down cleanly, I can unplug everything and put this away. We can get to it later. All right, any questions before I move on to the next thing? Okay, great. Thank you, tester. Okay, so let's go to the computer. Anyway, so sign up. We have this product number 4950 if you'd like. Okay, next up. So we're doing more bones boards. I don't remember if we covered the DVI board last week, or maybe it was in the overtime. Anyways, I'll just go through it really fast. So the bones board is this minimal RP2040 design that I can swap in different components. So I ordered the first prototype PCBs. Once everything's working, I'll publish the files, but I'm not going to publish files until I have some rough idea if it works, because I don't want to give people boards if there's a mistake in them. I'd rather just fix the mistake. So let's look at basic top. Let's actually go to the let's go to the other ones that I made, and we'll go to that one last because that'll make more sense. Okay, so the first one I did this week that's new is the RFM module. So these are LoRa or FM, ASK, etc. radio modules. Basically, a lot of the boards that I've made with the Feather 32U4 XYZ or the Feather M0 XYZ, I'm kind of porting it to the RP2040 because even with the extra flash memory and all the extra components, it's still cheaper and easier for me to manufacture with the RP2040 than the Atmega or SAMD. Those chips are annoying to get still. They don't have a lot of RAM. The RP2040 is great with Arduino. It's great with CircuitPython, great with MicroPath. It's a great chip. And I feel like there's more future to it. So I'm interested in kind of moving on, as it were. So this is the module. So this module, it's like a square radio. Sometimes there's a tin on top. It has a couple different part numbers. There's the RFM69, which again, FM, ASK, basic like radio module, and it has like basic like receipt transfer, so you can like send it, it'll CRC it, tell you that it was received. So you can do like addressing and not encryption, but like it's very rough encryption, not like true encryption, but like it's a little, it just like XORs it or something. And you can have either a wire antenna by soldering it into this hole here. I have like a through hole, or I'll have a UFL connector here that you can then connect to an SMA adapter for a bigger antenna. And then there's a little slot here for stomach UT. So this is an SPI connection. And there's actually a lot of IO pins, this IO 3, 4. There's like these extra pins that you can use. IO 0 and IO 1, I think, are used for interrupt and mode state. And so those are kind of the most important. But the others are also used. You can check the data sheet. They're used for, for like different settings, or you can like use them to like modulate the signal or something. So what I did is, there's 6 IO pads. So I connected them to those, we have 8 extra GPIO in order. I'm using the SCK, the mostly an SCK clock for the main SPI port, because these modules communicate over SPI. Then chip select and reset. Those have also 10K pull-ups on them, just so by default it's disabled. And then the IO 5, they're out of order because it turns out just to route them, it was easier to put them a little bit out of order. And then you can also get this LoRa radios in the same, it's like literally the same pinout and same size. And so if this works, I'll just swap out LoRa and I'll make a LoRa version. And then you can use this as a little like LoRa WAN endpoint. You want to have a router to get to the internet, like a Things Network router. But you could use this to get data and have a little network, maybe not a mesh network, but like a Starpoint network for data. I really like the RFM series. They're really inexpensive and they work really well. And I think they have like a couple 100-meter range. They have very good range considering that they're only a couple bucks, very cheap. And so a really good pairing for the RP2040, because the RP2040 has lots of RAM and like flash memory, and you can store files and configurations and send stuff. So, it's going to be a nice upgrade from the SAMD21 or the ESP, the SAMD21 or the Atmega 32U4. The next one I did today is an e-ink add-on. So I designed an e-ink Trinky but it turned out it was like almost feather shaped anyways. It's really hard to, it's like, okay, it didn't have the battery, but it had kind of everything else. It was like almost feather size. So I was like, okay, forget it. I'll just make a feather version of this board. Um, so again, same, bones part over on the left. And then on the right, this is a standard 24 pin e-ink connector. What's really nice is almost all non e-reader e-ink, like all the sign display e-ink displays. They're all 24 pins. They have different code, but at least the hardware is the same. So you do have to swap the code, but that's not too bad. So everything from like the 7-color e-inks to the tiniest, 1.5-inch e-ink display. And Mr. Ladyada and I wanted to, before the chip shortage, do like an e-ink starter kit. And so we feel we can actually do that now. We should get this design done.
Yeah.
So this has got a STEMMA QT, so you could have like sensors or maybe like a button board or something if you want to do that. Of course, all the feather layout. There's a lot of capacitors. This is a little, converter. There's a lot of high and low voltages generated. So by the e-ink chip itself, you just have to provide the inductor, capacitors, and diodes to do that. And then there's another STEMMA QT connector over here. And this is pushed back a little bit just so I have clearance around these mounting holes. So you could, we might make like a little feather mount that you could then put any ink display you like. And then, just to make this a little bit more low power friendly, the NeoPixel, because I had extra pins, ironically, ink displays don't actually need that many pins compared to, that RFM module, which needs clock, data. Sorry, it needs a full 3 SPI pins, chip select, reset, and then 6 IO. So it's like, it's quite a few. E-ink displays, they actually only need like 6. They need clock and data, but they don't need data in. They don't send back data. And then chip select, DC, reset, and busy. So only 6 IOs. So I had 2 left over, so I made the NeoPix Power. So you could power down the NeoPixel. So that makes it just a little bit less power consuming. So you could probably use this. The RP2040 isn't amazing for deep sleep, but you could go into some semi-deep sleep modes to reduce power consumption. It would never be as good as an ESP32 because that can like go down to microamperes. And I think the RP2040 can maybe go down to like 1/10 of a milliamp, but maybe 2/10. I don't think it goes below that, whereas ESP32s easily go to 50 microamps. That said, it's a powerful chip. And then another thing I thought would be really useful for this is you can actually use, what the Trinky would be is you could actually connect this to your computer. And then on this chip, you run the U2F firmware, which is not the same as the UF2 firmware. And it's not the same as like the encryption standard for keys either. It's like I think it's called like Teeny UF2. Hold on. What is it called? We have it Teeny UF2. No, Teeny U2F. God, what was it? It was like the USB to, oh man, I'm not gonna, U2IF. Yeah. All right. So USB to interface. So there's like U2F, UF2, U2F, U2IF. Right. This is a little board that basically turns a USB into SPI and GPIO converter. So you'd be able to use this and it has all that power supply stuff. You could use this on a computer to draw to an ink display. So it'd be like a USB to ink driver board that you would run CircuitPython libraries natively on your C Python computer, which is again the power of CircuitPython is the same driver code would work on the microcontroller or on your computer through the microcontroller with U2IF. And it looks like, wow, it looks like Main actually got updated with some stuff too. Oh, that's cool. They added a Hub 75 interface. I'll check that out. That's kind of neat. Um, okay, so where was I? Whoops. So, oh, right, I was an Eagle. So that's done. So I did that today. And I routed all these lines. And so I'm looking forward to getting this made. And then, like I said, the last one that we did is the DVI, and that will lead us into the great search. So the DVI one, again, I don't remember if I talked about it, but I'll just do it again. This uses Pico DVI, which is a bit bang DVI driver that allows you to connect to HDMI compatible displays. Like the connector is called HDMI, and HDMI adds Ethernet and audio, but DVI, the digital video interface, is what you can mimic here. So it has the HGPIO in order, and we can use the Pico DVI library, and then this is your kind of bog standard large scale HDMI display. Let me see if I can have a Raspberry Pi I can show on the overhead. I'll show in a moment. Oh, look, it's green circuit boards are transparent. That's kind of cool.
It's not out yet. Don't ask. Transparent circuit boards.
Transparent circuit boards to green screens. So you can use that, and then you can connect, and you can do 640 by 480 pretty easily. And then I think we got 640 by 480 pixel doubled because you have to, you can't fit more than 320 by 240 by 2 bytes per pixel in RAM. Like it actually takes up a lot of RAM. And I think we got it even up to 800 by 480 pixel doubled. So it's 400 by 240, but still, it's pretty cool. We'll do more demos once I get this board back because to be honest, actually getting Pico DVI running on like a breadboard with all those wires is very tricky. You can do it, but it's a little finicky, whereas you really want to have a board with these nice short wires and those resistors in line. When we tried doing this with our Feather Scorpio, the driver was actually a little bit too powerful. We had to lower the pin drive strength because having all these pins toggle so fast can actually create some EMI noise that feeds into the USB port and cause disconnects. Something to watch for if you have if you're ever having a high-speed interface on a microcontroller board that's only 2-layer and not meant for it. Try lowering the drive strength of the I/O pins. The RP2040 I think does 2, 4, 6, and 8 milliamps. 8 milliamps is great for LEDs, nice and slow. If you're driving something like this DVI or 8 neopixel strands, lower it to 2 milliamps because the more current that's sloshing around, the more EMI you're going to get. So lower it, and everything worked out great. So any last questions before we go to
Let's do some great search.
Great search. Okay, search it up.
Where in the world is that part I need? The Great Search with DigiKey.
The Great Search brought to you by DigiKey and Adafruit. Every single weekly data user power of engineering to help you, yes, you find the things you want, need, gotta find, gotta substitute, gotta get going on in your designs on digikey.com. What is the Great Search of the week this week?
Okay,
Ladyada.
this week on the Great Search, I'm going to be talking about HDMI connectors for DVI boards, which is a very common connector that you've seen. Let's go to the overhead and I'll show it off. As seen here on this Raspberry Pi computer, this is even HDMI licensed. One thing, there's lots of articles you can read. So the HDMI standard contains like Ethernet and audio and DVI, the digital video signal. Be aware, if you actually use the HDMI marking, you owe a licensing fee. If you use the term HDMI, you will have to pay a licensing fee. So don't slap, if you're not actually using HDMI, if it's just the connector, it's a DVI connector. It doesn't have to be HDMI, but they clearly paid because they have the logo. But you've seen this before. Also, DisplayPort, by the way, is pin compatible. There's little adapters that you can use to make it pin compatible. And then DVI-D as well. Those are 3 connectors that use the same pin, video encoding. You choose either one, but most people are familiar with this HDMI connector. And what's interesting about this HDMI connector is it's kind of universal, thankfully. We're going to look on DigiKey for an option. You'll notice when we get there that there's a lot of suppliers and they all have like one connector, and then they're all the same. They're pretty much all compatible. I mean, I didn't manually check the pins, but like dollars to donuts, they're all going to fit on the same footprint because it's pretty standardized. And another thing is that you see that the pins are surface mount, right? There's like 19 pins and they're SMT. And then the mounting tabs go through the circuit board, and they actually, this is a standard thickness circuit board, and they kind of poke out. And these connectors, so they're oval slots. Let's go to the computer and I'll show you. You'll have to define the oval slots in your board so you can see, like in this CAD file, it's a little faint, but you can see it. There is the pad, which is a really nice big pad. I want big mechanical connection. And then you have the oval slot defined on the milling layer. Your board house should know what to do. They'll make a through hole plated slot. And then make sure to also have the cream layer. Maybe I'll turn off ground. So you'll see it's hatched. Solder paste is deposited onto these pads, even though there's a slot in it. And then what happens is that when the connector is placed through these 4 pads, these through hole tabs go through the slots and kind of push the paste as they go. They kind of like, slot in, squish the paste in, and the paste kind of hugs the connector. As long as the slot, make sure the slot, you don't have too tight, but it should be like a fairly good fit. And then when you put it through the oven, you don't have to wave solder or selective solder it, because that paste will, the SMT pads will kind of get it into the right spot. And then the through hole tabs will solder and wick into the slots, and you'll actually get a really good mechanical connection, even though you'd think like, oh, is this like SMT-ish, through hole-ish. You can use wave or selective, but you don't have to. And I've done plenty of boards that use this DVI connector, and you do not need to have a secondary process for them, which is a really nice design decision. I'm really glad that whatever consortium made this, the HDMI consortium that made this connector design, they did a really good job. So let's go to DigiKey. And this is an HDMI connector, but I'll show you also there's other connectors you can go to. USB, DVI, and HDMI. These are kind of grouped together, and it kind of makes sense. They're sort of similar connectors. Don't forget that HDMI does come in micro, mini, and like standard huge HDMI. The micro HDMI is very small, but the mini looks deceptively like the large one. So just make sure you have the right connector when you're buying it. So let's go for active. So there are a couple different generations for the HDMI. I think they changed, how much resolution they can pass. Honestly, I'm not using Ethernet in this case, or 4K. And let's see, I only want 1 port, which is the only thing that's selected. I do like the new DigiKey that kind of gray out everything that wouldn't be selected. And then let's do normally stocking. And this only gives me about 42 options. So there's a couple of like funky stuff, like this is a panel mount one, but you'll also see a lot of like this and this. These are equivalent, and this one, these are the same. These are all very similar layouts, and you can almost certainly use the same footprint for all of them, which is wonderful because you don't have to doesn't matter. We can go between suppliers if you need to. There's also versions that are, this is, panel mount, but like it's not, it's panel mount with the PCB. So this is mechanical stability, which is good if you have a design where you don't want like people, they shove the HDMI port in and they kind of like jiggle it around. Then you don't want them to tear off the connector. A couple more panel mount ones. You don't want panel mount though. So let's go with, and there's also micro. I'll just show you that really fast. Let's see. They do have a micro. So micro, it looks like HDMI, but it's tiny. Okay, so let's skip that, clear, and then go back to HDMI. There's also, I did see there was 1 plug type, which is kind of cool. So if you wanted your board to plug directly into an HDMI port, this though, I believe it might hug the edge of the PCB. Let's see what they do here. Yeah, it's solder tails. So this is designed to have a 1.2 millimeter PCB go through, and then you do have to, it's like a weird process. Maybe you could do paste on either side, but I think it's a hand soldering process. So So I don't use this as much because it's kind of, it's, you know, it's more complicated than just pick and placing. So that's another option, but we're going to go with HDMI and then receptacle. The thing is, I think the DigiKey search sped up. Their web team rocked it out. Okay. And then we want it to be, I think, horizontal. Yeah, there's vertical that would be sticking up. Let's just see what that looks like. So this is the vertical style. Ooh, that's kind of funky. So this is definitely not pick and place. You're gonna have to through hole, you know, you're gonna wave solder or selective solder this, but like it's like slim style. I agree. So let's do horizontal. And we don't want flange. Mid mount, by the way, means it's in the middle of the PCB. That also usually, I mean, sometimes it's like sunken in and you have like those legs that stick out, sort of like spider legs. But I'm going to go with the standard mount. So these are the standard HDMI connectors. Again, they're all going to be compatible. They're all basically the same design. So let's look at some good pricing options. I'm going to, you know, probably buy about 500 to start. So let's look at pricing at 500 pieces. And I'm going to exclude marketplace just because I like to have instant shipping. And there's a lot, and they, you know, they range. And what are you paying for? I mean, you know, some of them are going to have gold plate. Some of them are going to be able to do HDMI 2.1. They might have different temperature ranges, but they're all going to have they're going to basically, and some have different mating cycles, but they're basically all going to kind of be the same. You also might have a specific maker that you like you really enjoy Amphenol or Molex or whatever, but you'll notice pretty much every company came in and was like, okay, we're going to make one of these connectors. It's like a standard issue thing, but I do like CUI. So this week's product pick for the Great Search is going to be the HDO419 THTR, which is from CUI, and is, you know, a standard HDMI 2.1 19 position half through hole, half surface mount, reflow compatible HDMI connector. A lovely board, and you can see they show you how to do those mounting rings. You can do this in a pick and place process.
That's your Great Search.
Where in the world is that part I need? The Great Search with DigiKey.
All right, here's some questions.
Yes.
I believe it's been asked before, but would you confirm again if there is one of the latest Feather RP2040 bones will be one with the ESP32 airlift coprocessor? It wouldn't be price competitive Pico, but would be Feather standard pinout, have stemma QT, a USB-C interface, integrated battery.
Yeah, I think I will, but yeah, it's not going to be. There's no way I'm going to be able to. I mean, I can't even buy the parts for the same cost as a Pico W, but there is some value to it. So I'll probably do one with the ESP32 mini on the end, and yeah, it's like a coprocessor. Yeah, maybe some people find some use in it. I'll just have to be clear. It's not using that Cypress chip, and we don't have like Bluetooth support for the airlift, and though in theory, you could do it.
Okay. And that's it. We'll,
Okay.
I spied HDMI, good idea? Question mark. And
We could do that. You'd have something, we have code that mimics DVI as an ILI 9341 display. It's something that we're working on where you would have SPI in and then DVI out, but we have to first get the DVI stuff working really solidly. But then, yeah, you would treat it sort of like an ILI 9341 display, and it pretends to be like a 320 by 240 display,
okay.
but it's like HDMI.
Any chance you've been able to get around to working on that ABLICS-35710 at timer breakout?
Nope, I have not.
All right. Okay, we'll see everybody during the week. We got lots of videos, surprises, and more. Thanks so much for joining us on this Sunday Desk of Ladyada. See y'all later.
Thanks, everybody. Bye.